I'm Mark Tomasovic, and I'm a principal at Energize Ventures. Energize Ventures is an investment firm that invests in digital technologies for energy and industry. We have about $1 billion under management, and we invest in technologies that can make analog industries more efficient, more sustainable, and broadly use things like machine learning or AI to optimize performance. I'm joined by Ali Reza, the Chief Digital Officer of ChampionX, and Brian Yutko, the Vice President at Boeing and the Chief Engineer of Sustainability and Mobility. So I thought I'd just kick it off and ask the panelists to give us a quick background on themselves and their organization. Ali, let's start with you.
Sure, thank you. So my name is Ali Reza. I'm the Chief Digital Officer for ChampionX. ChampionX is a oilfield services company, but it's pretty unique because they have this equipment that we provide into the oil field along with the production chemicals as well. So that puts it into a very unique position. My own background, have been with this company for about 6 years now. Prior to that, about 10 years with Honeywell and some of the software companies prior to that. I started my career 30 years ago in oil and gas and still continuing with that. Kind of stuck with this with this oil and gas phenomenon now. But it's glad to be here now. Thank you.
And Brian, would love to hear a bit more about yourself and your organization.
Yeah, so I'm Brian Yutko. I'm Boeing's Vice President and Chief Engineer for Sustainability and Future Mobility. And I oversee the company's interests in developing advanced technology for future products, which may be things like zero emissions electric aircraft, autonomous aircraft, and these sorts of kind of fun subjects. So I also sit on the board of directors at Whisk, a joint venture that we have, which is developing an autonomous electric aircraft. And so when I see, can't remember the name of our panel, something, asset optimization and performance management, I think about a lot of different fun aspects of that kind of sterile subject, which to me relates to both robotics. How do we think about optimizing a lot of the new products and machines that we're going to make, and how those are operated, but then also how do we think about transforming existing aircraft that we're operating today and using that kind of the learning that we're putting into developing some of the new products to do that optimization on the legacy installed fleet that we already have.
Great. Well, would love to just kind of set the stage. Everybody wants to be more digital these days. Everybody wants to use AI or machine learning or you name the buzzword and incorporate that into their organization. I'd love to hear a bit more about your organization specifically and what you've seen as the catalyst for kind of that digital innovation or setting up these innovation groups or the catalyst for wanting to use more AI in day-to-day operations.
I guess I could start, which is, differentiated capabilities. So, I think that certainly, I have an academic background where folks talk about these things in very sort of abstract sense. But where the rubber really hits the road in industry is thinking about how do I actually deliver differentiated capability. In the time where I spend a lot of my time, which is, robotics, frequently, one of the questions is always, where do you use, how much AI and where do you use it and why not machine learning here and there? And typically, the way that we think about it is right tool, right job, right time. And so that doesn't always mean that you need the world's most sophisticated algorithm to be applied everywhere. It just means that you need the right tool at the right job at the right time. Now, accomplishing that is actually really hard, and non-technical things get in the way. So, how do you acquire capability? How do you create capability internally? How do you get it into the flow of new products? How do you support aftermarket and so on? And we could talk about some of those things, but fundamentally, the way that we think about it is just right tool, right job, right time.
Yeah, and I think for ChampionX, it started by virtue of two things. Number one, the product that we actually take to the market. And we realized that we needed to get to the point where predictability is important, in order to get more reliability out of the equipment set that you have out there. Along with, that if you talk about the sustainability of it, and the resource availability, and also the right product at the right time with the right schedule and right people as well. So that was one portion of it. The other thing that actually triggered this whole AI journey was more of internal efficiency and productivity as well. And I think that was also driving the internal processes and the optimization of those, and then using a lot of AI algorithms there as well. So those are the two things that actually kind of started this journey, and then now we are seeing more, these are merging together as we are, moving forward, where we can see the profitability out of it for both us and for our customers as well, along with the safety, security, and efficiency of it too.
Great. Well, we'd love to dig a bit deeper on the subject and talk about more of the specific use cases that both Boeing and ChampionX uses in which they use AI. Could you just kind of go a bit deeper onto what are kind of some of the specific use cases for AI in your industries?
Sure. So we provide equipment for oil and gas, right? Especially artificial lift. The first stage of artificial lift, when oil stops coming by on its own, is called the ESP, the submersible pump solution. And when the pump works, it actually pulls in the water, oil, sand, and air, and it sucks it to the ground. Most of the time, what happens is that as it's pulling in, a lot of air slug comes into it as well, and the pump, which is actually rotating, it actually gets heated up because the fluids are actually cooling the pump down as well. And then with those air slugs happen, it kind of disrupts the operation. Sometimes to the point that you have to pull the whole equipment out. That thousands, millions of dollars of expense there as well. So that was an interruption. That was a problem. That was a productivity issue for us. And that's where we started our journey on AI as well. And now we are at the point where using some of those algorithms, using some of those machine language solutions, we can see or we can predict when the gas slug is going to happen in advance, so that we can take some actions in order to either slow down and make sure that we can let this gas slug pass, and then getting back into the operation. That reduces the amount of unplanned shutdowns that we talked about considerably for our own asset, because we actually leased a lot of assets to the market as well. So for our own assets, we have seen a lot of productivity there, and then reducing the unplanned shutdown, reducing the pulling out the equipment for those reasons as well. So that's one part of it. Going forward on the chemicals area, I mean, predicting corrosion, predicting scalability or scaling into the pipes is another thing that we have been actually working on in order to predict that in advance, so that we can feed in the right kind of chemicals to avoid that scalability in advance. So those are a couple of just quick use cases. Along with that, we have been working. Actually started with Spark a long time ago in monitoring compressors, especially reciprocating compressors and engines, where now we are at the point we can predict the failure of a valve on a compressor, for example, at least 6 weeks in advance with 96-97% accuracy level. So those are these are still learnings that we are actually bringing to the table with partners and our customers as well. And I think this is really moving in the direction where we can see the benefit of deployed analytics out there, especially the data analytics through AI.
Yeah, for a company like Boeing, Boeing's the world's largest aerospace company. And so if you think about these kinds of capabilities that we're talking about here as tools that are used for the right job at the right time, I'll give you a few examples. But the first thing I'd say is this shows up everywhere, literally everywhere. And so just a few examples from kind of, you're sitting in a building right now, which is related to a JV that we have with Spark Cognition, obviously, that's focused on SkyGrid, which is focused on airspace integration and operations of unpiloted systems of all types. And so you've seen today many examples of how more automated systems can provide greater capability in that kind of an environment. And that's just one environment. If you think about building new airplanes, so building unpiloted airplanes, the kind that we're building at places like Wisk, we need these kinds of capabilities to do detect and avoid to create very safe unpiloted systems. So you think about, how do I take an optical system, an optical sensor, a lot of other kind of sensor types, and automated process that information together, fuse all that information together, discern what's actually happening in the environment, make decisions about it. There are various kinds of algorithms that all need to be in the middle of that process in order to enable that to happen without a person doing it for us. But that doesn't also mean that all of this is removing people either. So a lot of those capabilities that we're developing in unpiloted systems, they'll actually go into piloted systems as well, which is one of the things that I don't think a lot of the industry appreciates yet. How do you continue to improve the safety of the air transportation system? Well, we can provide pilot decision support tools. So today, when you file a flight plan, we're no longer filling out flight plans on pencil and paper anymore. I mean, some people do that, but right now, a lot of that is automated. A lot of that is automated through tools like ForeFlight. I'm a pilot and I now file all my flight plans through ForeFlight. I used to go in and type out individually each of the waypoints that I want to fly to. Now, actually, I have the ability to receive suggestions to me as a pilot to between origin and destination. This is the likely best path. And so, these kinds of things are showing up everywhere. And those are, robotics and pilot decision support tools are some of the most kind of visible, and we think I spend a lot of time on them. But also, if you think about manufacturing, how do we prevent FOD, foreign object debris, in facilities when we're producing airplanes? Well, we could do that with optical sensing right now to be able to look at composite plies as they're being laid down to understand, is there debris that's going to be put into a composite matrix before it actually appears in the composite matrix. We can observe the operating environment to make sure that tools are being placed where they should be. When aircraft are in the aftermarket, we could do things like predictive maintenance. When does this valve? Rather than the engineers that designed the previous generation aircraft, the time between overhaul was all based on hours. Now we could do the things that are performance-based management to make sure that we're sort of most optimizing how that's happening. And so the thing I'd say is it's literally everywhere. But it also can't be kind of forced into a situation where it's not the right tool for the right job. And so I just fundamentally think about these things like tools, and as they become more capable, they start doing more jobs. And so that's how we think about it.
Completely agree. So there's so many low-hanging fruit. There's so many opportunities to use AI or machine learning to improve day-to-day operations or processes. The industries that we operate in are pretty risk averse. And historically, they've been slower to adopt digital technologies, and the sales cycles are extremely long if you're a digital tech trying to sell into these industries. And the reason why I think that is because we're operating, heavy equipment or, flammable hydrocarbons, and we're naturally more of a risk averse industry than, say, big tech or something. For example, the phrase at Facebook in the late 2010s was move fast and break things. Imagine trying to tell a CEO of one of our companies to move fast and break things. It does not compute. So my question would be, how have you seen some of those challenges to adopt digital technologies in our industries, which are by nature higher risk? You're not dealing with a line of code, you're dealing with people's lives. And then how do you fit that kind of adoption of digital technologies into existing procurement processes or apply it to aging assets that could be higher risk? How do you kind of square that where our industries as a whole are probably more challenging to adopt new tech or new startups than maybe other industries?
Jim, do you want to start?
So you're right. I think oil and gas, especially, we are known as the laggards, especially upstream oil and gas, right? However, there's a reason for it as well, because there's so much at risk when we are actually talking about these assets. It's a asset risk, it's life risk as well. So there are so many out there. So the mantra in oil and gas is seeing is believing. Prove me if it works. Show me 3 or 4 different places that it works. And then there are some leaders that will come out and say, yeah, let me do a pilot with you. And then that pilot could be extended for whatever amount of time. But I really want to see if it works or not. And then once it happens, then the other one will not just jump in right away. The other one will say, okay, let me have a pilot with you as well. So that's a struggle, especially in the oil and gas environment. But we have seen now in last couple of years, and I think some's been driven by COVID and some driven by other dynamics in the marketplace as well, that we are seeing that the adoption of technology is getting a little better, especially in oil and gas area. And people are more open to do this. Now, there are 2 schools of thought there. One is, I can do it by myself, so let me try to do it by myself and have a team come together. or I can rely on someone who can actually bring that expertise to me as well. So I think these two school of thoughts are still kind of growing, but at the same time, again, they have to converge at a certain point, and that point is still already here yet. I don't think so, but I think there's still a lot of collaboration that's happening as well between these. And then some of the common standards, like for example, the OSDU, you must have heard about, where they are bringing this data, factory at the common level. Those activities are actually helping in identifying what data is shareable, what data is not shareable, and how I can how I can make use of the shareable data in order to actually use some of the learning that I have done in one part of the industry into the other parts of the industry as well. So I think it's about finding out the real business value out of the technology that we deploy, and then what are the approaches that we are actually deploying those technologies to, and how we are going to converge eventually at some point. Are we there in oil and gas yet? I don't think so.
There are airplanes that are flying today that are flying code that was written in the 70s, and it's written in Fortran 77. And I wrote some Fortran too. It's a first language that I learned. Today's air traffic control system actually operates by, I mentioned, people are not generally writing paper to do flight plans anymore, but the air traffic control system is actually still operating on writing out tapes. I don't know if you've ever seen this before, but air traffic controllers actually write down via hand. They write down on a piece of paper and hand it to the person that's next to them to do some of the aircraft handoffs in the air traffic control system. And so, I suppose, validate your question, the aerospace industry is unbelievably safe because it figures out the right way to do something, and then there's a very high bar to changing it. Now, at the same time, what's really interesting about the aerospace industry is, if you think about right tool, right job, right time, is the aerospace industry has also been absolute pioneers of things like machine learning and artificial intelligence in certain applications for the right tool at the right job at the right time. And so, if you think about things like, the aerospace industry has pioneered some of the most advanced methods of producing composite, high performance composite parts. Those processes, from a design standpoint and a manufacturing standpoint, use automated processes, use machine learning as parts of that process. So that's the right tool for the right job at the right time. Now, in our industry, there are these kind of big bang moments where you get a chance to do something new, and they don't come up very often. And so what's really exciting about ventures like what we're doing here with SkyGrid, with Spark Cognition, what we're doing with Whisk, or we're doing in some of our other products, is we have the ability then to take this kind of generational change where all of the R&D that's kind of being developed in the build up to that has this moment where you get a chance to do something new and to set a new standard and to ultimately show that it can be safe. In the end of the day, the threshold in aviation is that the bar can never get lower. And it's really difficult to, if you haven't worked in the aviation industry, to deeply just feel what that means, viscerally, that the safety bar can never get lower. But it does show up everywhere. When you start thinking about putting a new technology, it doesn't matter if it has a benefit from a performance standpoint. It doesn't matter if it has a cost benefit, unless it can maintain or raise the safety bar. And the optimistic viewpoint that I have about these kinds of technologies is that I think, based on a lot of the work that we've done to date, and actually some of the pioneering applications in the defense space, that there is the opportunity to show that we can raise the safety bar by introducing some of these technologies. And so we're right at this precipice where we'll be able to have this next kind of generational change and introduce them all. And then that becomes the standard. And so now everyone has to do those things.
Great. Well, Brian, you talked about your joint ventures. Ali, you talked about using a pilot to kind of integrate more digital technologies in a more risk-averse way. Can you talk about how you can structure some other different forms of incentives, or structure your organizations to adopt digital technologies, maybe through even investment into certain companies? Or are there any other ways outside of maybe joint ventures or or pilots that you can bring a bit more digital tech into the organization?
I love this question because it's as someone who loves technology deeply, I also found along the way that what I really loved was technology that ultimately mattered. I started in an academic background and I was working as a research scientist at MIT for some time. And while I loved it there and I loved the environment, I realized, well, I actually want these things I want someone to fly on the airplane that uses the algorithm. I don't want to just write the algorithm. I want it to actually happen. And so when you go into places like Boeing that have this like incredible capability, one of the questions is, how do you start to transform it to these new kinds of technologies and bring in some of the capability? So I'm actually a big believer in the kind of outside in open innovation. There's a lot of terms for how you do this. To me, that's a spectrum. Everything from things like acquisitions. I got to Boeing via an acquisition of a company that I was working at, through joint ventures, through venture investments. So Jason McLean, who's here in the crowd with me, he leads our venture work at Boeing. We have a close partnership with Brian Shetler, who's also in the crowd here, who runs a corporate venture capital group. And then if you go even further, so then, if you step back from investing for that investment spectrum, then you could also do things like setting up the right environments, the right kind of playgrounds for companies that are developing really innovative new technologies to come in and do joint development and to have the right kind of interface with a big company like Boeing to introduce their technologies. So I guess the last thing I'd say on this is, when I started outside of Boeing, one of the things that I realized about a big company, like a big successful company like this, is it's not obvious where the front door is. When you're developing a technology and you want to say, hey, I've got a thing and I want to put it on your widget, it's not obvious. Like, how do you you can't just email, like CEO at Boeing.com and it doesn't just appear on the airplanes. So there needs to be some receiving mechanism. And that's a lot of the capability that we're trying to set up at Boeing, is how to do that kind of joint development with early stage, mid stage, late stage, so that we can be a pipeline to getting those things on our products.
I agree. So in oil and gas, right, I think one recognition that's there is digital is an enabler for us for achieving that safety, reliability, efficiency as well. So that recognition is already there. Now the question is how actively you actually pursue those areas. So for example, in our company, in ChampionX, we have been actively pursuing those, we would call it either adjacency or a blue sky kind of an area. So for example, we actually acquired a company, Scientific Aviation, in methane emission management. So now we have a portfolio which is very digitalized, which basically allows us to basically sniff the methane by having those, we call them SUFIs, and basically using some of the analytical engine in the background to calculate where it's coming from and how much the emission is. Basically, not only identifying it, but also quantifying it as well, right? So that's a solution for the methane or in the emission area, which is kind of an adjacency to us. But at the same time, we also invest into some other new technologies. So for example, there's a company I'm on board of, it's called Ping Things, out in the DC area. And what it is basically a time series database, which has very special algorithm running in the background, which allows you to, go through, multiple records very quickly. So those are investment that we actually make on the basis of short-term and long-term view of the company. And a lot of that is focused on the new digital technologies, especially on the AI side, and things which are actually helping or enabling the AI as well. So there's a lot of activity in that area. Again, as I said, both short-term and long-term, and some are organic, some are inorganic as well.
Great. Well, we're wrapping up on time. We have about 2 to 3 minutes left. Wanted to get each of your perspectives on what's the future. Where do we see the industry going? Where do we see the adoption of AI going? Where do we see AI itself going? What's the future look like at both your organizations?
Well, my title has the word future in it, so that's exciting.
So you should be an expert.
Yeah. So I've got that sorted out. At least in the so if you think about commercial aviation for a second, I really firmly believe, have for a decade, it's still playing out. There's 2 things that are coming to commercial aviation. One is autonomy. So we will have automated systems that are doing a lot of different stuff. Passenger or cargo airplanes, small drones, all these things. So there will be a proliferation of autonomous systems in aviation as one kind of big mega trend. The other big mega trend is sustainability. And so the airplanes of tomorrow will be, zero emissions. They will be more electric. We're going to see a great fragmentation, I think, in the kinds of airplanes that you have access to in terms of consumers flying in commercial aviation. Those two trends to me are like a railroad track and the train is driving on them. They're not related to one another. Autonomy doesn't depend on, battery electric airplanes, but they go together. And so if you think about how these new generations get created, that train is running on those tracks. So that's kind of what's happening there. And then, in the defense side of the business, I think you're likewise to just see a dramatic proliferation in terms of autonomous systems. And this is going to be a multi-decade trend. And I think if you're on one of those rails, then you're working on the right things.
Yeah, I agree with that completely, Brian. So somebody mentioned in 2011, I think some gentleman from Forbes, he said, software is going to eat the industry, right? And then afterward, back in 2019, 2018, somebody said that AI is going to eat software industry now. I think we are in that trajectory already. I think if we go in, there's a lot of autonomous operation in oil field as well. However, some of the traditional sites will still be having a kind of a hybrid for a while until that level of confidence get developed. So in the next 5 to 10 years, I really see many more technologies kicking into these kind of legacy businesses and make their way in, and the adoption will be the real game here.
Great. Well, thank you, Brian. Thank you, Ali. That just about does it. Thank you all for joining today.